It looks like it's another fun-filled day in the land of trigonometry. And it looks like, oh my goodness, we want to go backwards. We want to find inverse trigonometric ratios. How do we go backwards? Now again, SOHCAHTOA helps me remember the ratios. And so the sine of an angle is equal to the opposite leg divided by the hypotenuse. Cosine of an angle is the adjacent leg divided by the hypotenuse. Tangent of an angle is equal to the opposite leg divided by the adjacent leg. So if I know the sides of the triangle, I can figure out the sine, cosine, or tangent. To go backwards, we actually start knowing the value of the sine of the angle, or the cosine of the angle, or the tangent of the angle, and then we got to figure out how long are the sides. Of course, I need a right triangle. Right? SOHCAHTOA works only with right triangles. If we don't have a right angle, we have to have a different method to go about this. So I pick one of the acute angles. Again, I'd like to pick angle A. Right? So inverse tangent. Notice how we write that. It looks like tangent, and it looks like it's raised to the -1 power, but that's not an exponent. That tells us it's inverse function. So when you see tangent with that little -1 on it, it's not an exponent. It's just, hey, we want the inverse function. We want the inverse tangent. Again, sometimes this mumbo jumbo makes a lot more sense when we do an example with numbers. But it's basically saying, hey, if you want the inverse tangent for the ratio of side BC over side AC, that's the measurement of angle A. Of course, same thing will go with inverse sine. If sine of angle A gets you value of y, then the inverse sine of y will get you the measurement of angle A. And of course, we have cosine. So we need to do inverse cosine. And again, these are just like the formal definitions from a textbook. Yeah, I think it'll make a lot more sense when we start playing with numbers. Now again, that -1 is not an exponent. The -1 tells us we're looking at an inverse function, not a reciprocal. Now, when you get into Algebra 2 and also something certainly in pre-calculus, instead of calling it inverse cosine, we're going to say arc cosine, because we'll be looking at a circle and we'll be looking at an arc, which is a section of that circle. And if the interior angle is at the center of the circle, the arc will have the same measurement as that angle. So when we get up to pre-calculus, instead of calling it inverse cosine, we'll actually call it arc cosine. And as I go through and narrate, sometimes I'm going to slip up and call it arc cosine or arc sine or arc tangent instead of inverse sine, inverse tangent, etc. Now, if I actually wanted the reciprocal, if I wanted 1 divided by cosine of x, that's a completely different function. That's called secant of x. Again, that's not something we're going to do this year. It's something you can look forward to. So if I want the reciprocal of cosine, I actually need the secant function. Same is true with sine and tangent. There are inverse functions for those, and there are reciprocals for those. IXL is kind of dicey when I start going into the geometry. If you've looked, you'll notice there's a lot of things popping up, and I don't know why IXL has some of this in geometry. Geometry, we usually do SOHCAHTOA. For the more advanced trigonometry, come back for Algebra 2 and Pre-Calculus, please. Surprise, surprise. Our best friends are here, the special right triangles. So without touching a calculator, let's find some exact values. Let's pretend I want the cosine of 60 degrees. I want an exact value, and I'm not going to touch a calculator. Well, cosine, of course, is adjacent over hypotenuse. Right? SOHCAHTOA is my reminder for that. So if I'm at a 60-degree angle, what is the adjacent side? What is the hypotenuse? Well, if I look at a 60-degree angle, adjacent side is 1, hypotenuse is 2, so the exact value is 1/2. Now, what if we're trying to go backward? What if I want the inverse cosine of root 3 over 2? What kind of angle am I standing in? Where am I if the adjacent leg is root 3 and the hypotenuse is 2? It looks like we're standing in a 30-degree angle. So the inverse cosine of root 3 over 2 is exactly 30 degrees. Ooh, tangent. What is the exact value of tangent of 45 degrees? Well, doesn't matter which 45-degree angle I choose, the opposite leg will be 1, the adjacent leg will be 1. 1 over 1. Of course, whenever possible, reduce the fraction. Exact value tangent of 45 degrees is 1. Ooh, what if I want to go backward? What if I want to do the inverse tangent of root 3? Right? Instead of coming up with a ratio or a fraction for an answer, I'm trying to figure out the angle. How many degrees is that? Uh-oh. Root 3 doesn't look like a fraction. It might help if I rewrite that as a fraction, root 3 over 1. Now it's a little bit more clear what's happening. I need an angle where the opposite leg is root 3 and the adjacent leg is 1. What angle am I standing at if the opposite leg is root 3 and the adjacent leg is 1? That looks like it's got to be 60 degrees. Right? If you're at 60 degrees, opposite is root 3, adjacent is 1. So the inverse tangent of root 3 is 60 degrees. We've done cosine, we've done tangent. Let's do sine. Sine of 45 degrees, what's the exact value? Well, it doesn't matter which 45-degree angle I grab. Opposite is going to be 1. Hypotenuse is going to be root 2. Uh-oh. Square root in the denominator? I don't think so. Remember some of your Algebra 1 skills? We don't leave square roots in the denominator. Let's multiply by the number 1, because multiplying by the number 1 never changes the value. But notice how we disguise the number 1. We'll use square root of 2 over square root of 2. Of course, upstairs, the top of the fraction, the numerator, 1 times the square root of 2 is the square root of 2. Downstairs in the bottom, the denominator. Square root of 2 times square root of 2 becomes square root of 4. Square root of 4, that's just 2. Now I have an exact answer, and I no longer have the square root in the denominator. Well, we ever do an inverse function of sine? Where am I if the inverse function of sine is 1/2, right? I want the inverse function of sine 1/2. What angle are we talking about? Where are we if the opposite is 1 and the hypotenuse is 2? Looks like we're at a 30-degree angle, right? If you're at a 30-degree angle, the opposite side is 1, the hypotenuse is 2. Something tells me this is starting to make a little bit more sense now that you've seen it with numbers and pictures. Of course, as you've probably already wondered, we don't always have a 30-degree or 45-degree or 60-degree angle. What if I want cosine of 18 degrees? I'm not going to get an exact value. I'm going to get a decimal approximation. Of course, with a calculator, I got to make sure I'm set for degrees. And then I got to locate cosine. On some calculators, cosine is actually just one of the buttons. The calculator I use, it's actually a secondary feature. So I'm looking at button Z, and I notice that cosine is one of the secondary features. And so I have to select that. Cosine of 18 degrees. Looks like it's about 0.95. Of course, as a mathematician, you never start with just a decimal point, right? If I've got like 0.95, I'm actually going to put a 0 and then the decimal point and then the 95. That 0 is really just there to alert us, hey, a decimal is coming up. Otherwise, if you get in a hurry and you see the 95, you might think 95 instead of 0.95. Ooh, what if I need to go the opposite direction? What if I'm starting out with the 0.64? Now I'm trying to figure out what angle would create that answer. What's the inverse cosine of 0.64? Again, I got to go to the calculator. Got to make sure I'm in degrees. But this time I want to make sure I'm using inverse cosine. So if you have a cosine button on your calculator, inverse cosine is usually the secondary feature. Notice on the calculator I'm using, that Z button has cosine as the secondary feature, inverse cosine as the third feature. And it's just a little bit more than 50 degrees. So I'd say, hey, let's round it off about 50.2 degrees. What if I want the inverse sine of 5/13, right? Because sometimes we see it as a fraction instead of a decimal. No problem. With a calculator, I'm going to say, hey, I need the inverse sine of 5/13, making sure I'm set for degrees. And it looks like, about 22.5. All right. Of course, if I do a good job of rounding off, it actually comes out as 22.6 degrees. Don't panic. Review, we will. Right, this is actually the last new concept for this unit. And so we're going to start reviewing the next couple of lessons. Today, the IXL. It's just some more kind of throwback practice with algebra. And so the worksheet, besides having the new material, you might notice a couple of other questions from this chapter mixed in there.